Hello and welcome to helpyourmath.com. In this video, we are going to look at the law of large numbers. The law of large numbers states that in the long run, as the sample size increases, the relative frequencies of outcomes get closer and closer to their theoretical or actual probability value. In this video, we're going to look at an example of rolling one die. So die is singular for dice. It's the six-sided thing. We're going to look at the six-sided ones. Theoretically, the probability of rolling a 6 on a one-sided die, there's one way to roll a 6, there's 6 possible outcomes, so we would say it's 1 over 6, or 66.7%, or I should put all three of these, or 0.66 repeating, so we'll say 667. Those would be the three ways to express the theoretical probability. Now what we're going to do is we're going to roll a die a bunch of times. You can either get a die and keep track yourself. You can find a website that will roll a die several times. I'm going to use Microsoft Excel. So we're going to go there now. And what we're going to do is we're going to roll a die 20 times, although I'm going to use Excel to choose a random number between 1 and 6. And then we're going to just see what happens after 20 to see how close we are to the actual. So remember the probability for each number is 1 in 6, right? That's the theoretical probability. We're going to compare this to its empirical probability. Here I am in Microsoft Excel, and I'm just going to start labeling my columns just so I can keep track of them. So this is, I'm going to say roll count, and this is value on die. And what I'm going to do is I'm just going to say 1, and I don't want to just keep typing 1, 2, 3. Excel is beautiful with its formulas that it's capable of. I'm just going to say equals, and I just want to add 1 to the previous value. That's going to give me 2. And then I can copy and paste this formula as many times as I want. So there's my 20. Okay, so there's the 20 rolls. Now the value on the die, what I can do in Microsoft Excel is I can say Now for the value on the die, I can use a formula for that. What I want is I want a random number, so I start typing in random, and I want random between. I specifically want a number between 1 and 6. And again, I can copy and paste this formula. So what I'm doing since you can't see what I'm typing, is I'm doing Control-D because I am on a PC. If you're on a Mac, it is going to be something different, but I can do Control-D. Now notice that every time I enter something new in my Excel spreadsheet, these numbers change. So we're not going to really take them into account now because I'm going to have Excel do all of the work for me. But just when I get to the very end, we're just going to use whatever numbers appear at the end. But just notice that they keep changing, and that's okay. Now, I could just sit here and count the number of 1s, and count the number of 2s, and count the number of 3s. But I don't want to make a mistake, and that seems really boring, and Excel can do it for me. I'm going to have it count for me. So I'm going to say counts, and then I'm just going to put 1, 2, 3, 4, 5, and 6. See, it changes every time. And now, I want it to count the number of 1s that appear in those 20 values. So what I'm going to say is equals count if. And this says it's going to count the number of cells within a range that meet a given condition. And the range that I want, so I need to start with the range. I want this 2 to 21. Okay. And now it's telling me what criteria do I want. I want to know how many 1s there are. And it's going to tell me currently there are 2 1s, but you'll notice as I keep typing in the formula that it will change. Now there probably is a shortcut for doing this. I don't happen to know it, and I don't mind just sitting here and doing this. So I'm going to do this for all of the numbers, and it will keep counting for me. Okay, and then I just want to make sure I really do have 20, so what I'm going to say is equals sum. I just want to add these numbers up and make sure I really do get 20 here, and then that's what I'm going to use. Okay, so I'm done fiddling. I see the 20. Awesome. These are the data values I'm going to plug back in to my PowerPoint. So I'm going to open up my PowerPoint, and I'm just going to type, handwrite in the number of 1s. Whoops, I need to slide this over a little bit. The number of 1s is 2, 3, 4, 2, 4, and 5. All right, so now we're back in my PowerPoint. It's so beautiful. And in this PowerPoint, it says the probability of a 6. So we're focusing on just the number of 6s, just because I had to pick something. In this case, when I rolled the die 20 times, and on the very one it landed on, the probability of me rolling a 6 in those 20 rolls is 5 out of 20, which is 1 out of 4. fraction and decimal. I don't need to round to 3 decimal places because this is a terminating decimal, and it's 0.25. So 25% chance based on my 20 rolls that we're going to end up rolling a 6. Okay, now we're going to do this 500 times. Again, don't actually do it 500 times. You can find a website that will do it for you, or you can use Excel like I am. And let's see what happens when I roll it 500 times. I'm back in Excel, and what I can do is I think I can do these at the same time, just extend them way far down. I think I have to get to like 501. We'll find out, because if I'm wrong, I can always just adjust when I get there. Okay, so I have one too many. Okay, good. So I'm just going to delete and delete. And notice again, it's changing every time. Okay, so we're down to cell 501. Oh, that's what I thought. I just went down to 502 anyway. And now we're going to have it recount, but this time I'm going to go from cell B2 to cell B501. And remember how to do this. We're going to say equals COUNTIF, not COUNTIG, COUNTIF. And I'm just going to type it in because I don't want to go all the way down to the bottom. B2 to B501, comma, ones. Count those ones for me. And now I'm going to do the same thing here. You know what? I can use Excel to do the calculation for me. So I can say this equals this divided by 500. And there's my decimal. Beautiful. And then I can just Control D, and it's going to do all my calculations. Oops, of course, when I do that now, it changes everything. Oh no. So now I have to go back in here and change this. Okay, no more tinkering. Can't tinker anymore. Now we have 99, 82, 81, 101, 76, and 61. And here we have okay, I'm going to do the decimals first because they're right there, 0.198. And this would be 99 out of 500. 2, we have 0.164. And this one I can simplify because it's 82 out of 500, which is 41 out of 250 if I divide them both by 2. 81 out of 500 is 0.162. And this one would be 81, can't simplify this, out of 500. Probability of a 4, we had 101 of them, that's 0.202. Can't simplify that, that would be 101 out of 500. 5s, we had 76 of them, that's 0.152. 76, okay, so 76 and 500 are both divisible by 4. If I divide by 4, I end up with 19. And if I divide 500 by 4, I end up with 125. So 5s, we have 19 out of 125 chance of rolling a 5. And the 61, we have 0.122, which would be 61 out of 500. We can't simplify that. Beautiful. So there we go. All right. So based on this, did we get closer to the theoretical probability? Comparing the theoretical of rolling, remember we're looking at rolling a 6 here. The theoretical of rolling a 6 is 1 in 6. As a decimal, that's like 0.167. When we did 20 rolls, the probability of rolling a 6 was 1 in 4, which is 0.25. So that's not super close to the theoretical. How about 500? Are we getting closer to the theoretical? Because that's what the law of large numbers says. That as we do this more and more and we repeat the experiment more and more and more times, we should be getting closer and closer. This one we had 61 out of 500, and that ended up being 0.122. So we ended up dipping below it, but we did get closer to the theoretical probability. The last thing I want to do, just to really emphasize that we are in fact getting closer, is I want to look at the histograms of all three, and let's compare the 3 histograms. Okay, so I created a bar graph that shows the probabilities. The blue is the theoretical, so we see the blue are all the same. The orange in the middle, that's when we rolled the die 20 times, and then the gray is when we rolled it 500 times. So you can see, the blue is consistent, the orange is all over the place, and the gray is also all over the place, but it seems to be, kind of settling. And if we did this 10,000 times, we would have a bar that should be even closer to those theoretical probabilities. Okay, so now, based on your results or my results, do you agree or disagree, or do the results agree or disagree with the law of large numbers? I copied and pasted my beautiful chart. I don't know why it changed the colors, but it did, so we have new colors now. I would say yes, my results do agree with the law of large numbers. And if we did this experiment over and over again, we're going to get different results. But generally they should, although it is possible that they could not agree with the law of large numbers. But that's how probability is, and that's what ends up happening. But the more times we repeat it, the closer and closer these empirical probabilities should be to becoming the theoretical probability. This has been the first example in the law of large numbers. Watch the next video where we roll 2 dice to compare. One more thing before I sign off here. I just want to mention the shape of the probability histogram. For the theoretical probability, this would be a uniform distribution, right? Because if I only had the green bars, they all are the same probability, so they're all the same height. Just one thing to note about that, we would have a uniform distribution here, which I talked about in a previous video. Okay, one last thing before I go. Just in case you were curious how I did those formulas in Excel. I know this is like tiny font, but just so you can see what I did, I tried to spell it out exactly as I would do it. But for any formula you want, you have to always start the Excel with an equal sign. So you would say equals, and that acknowledges that's the indication to Excel. Oh, we're about to do a calculation or a formula. So these are the various ones that I used when I was creating my random numbers. The integers 1 to 20, the random numbers between 1 and 6, which is the equivalent of rolling a die, counting the number of numbers, and then just any other normal arithmetic operation. So if you want this, you can pause this, or you can email me if you know my email address, and I'd be happy to send this off to you. All right, so that's it for this video. Thank you so much for stopping by.